In the previous lesson, we learned about the infrastructure that a Daml application runs on, which includes Canton participant nodes and a synchronizer, and the benefits with respect to non-repudiation and data sovereignty that these provide. In this lesson, we're going to look at the various components that need to be built and operated for a functional Daml application. We're going to learn what components a Daml app typically consists of and how to decide on the component architecture for your application. As an architect of a Daml solution, you represent the app provider organization. When we discuss the costs and benefits of various architectural options, we consider them primarily from the app provider's perspective, although in some cases we also mention the costs and benefits for the app user organization. Your app typically requires these three kinds of components: Daml models, app backends, and app frontends, which we will explain in turn. The Daml models define the cross-organization workflows and serve as an API definition for the components interacting with these workflows. They are compiled into DAR files, also known as Daml packages. These DAR files need to be uploaded to all Canton participant nodes of your app users. The backends sit directly on top of the Ledger API and manage access to participant nodes. The backends utilize Daml parties representing the app provider and the app users, and Daml contracts to represent the state of the workflows between these organizations. Daml parties act on the ledger and read from the ledger at the level of an organization. Note that even though the diagram depicts the backend as single box, it does not have to be implemented as a single monolithic component. It's a logical component that can be implemented using a microservices architecture or any other service architecture preferred by the development team. The backends typically serve one or more of the following purposes: to automate on-ledger workflows. Steps in on-ledger workflows that do not require human intervention are automated using the backend. For example, in a customer onboarding workflow of a financial services app, the backend might listen to a new customer onboarding request on Ledger and advance it automatically once the provider's off-ledger Know Your Customer or KYC compliance system gave the green light to onboard the customer. To integrate with off-ledger systems. For example, running off-ledger anti-money laundering compliance checks or populating reporting databases while processing on-ledger financial transactions or initiating on-ledger financial transactions from an off-ledger pre-trade analytics system. It is crucial to understand the specific integration needs of your app users as well as the app provider organization, and put the backend infrastructure in place to serve these. To provision higher-level APIs, the participant nodes ensure that all your application's data is synchronized in real time across organizations. However, front ends and other systems often need to run particular queries over this data. The backend's job is to serve these queries from application-specific APIs with appropriate access control and performance characteristics. It is important to implement these queries in a way that scales to your application's needs. Using the Participant Query Store or PQS with application-specific indices is a good option to do it. To serve reference data contracts. A special case of provisioning a higher-level API is to serve reference data contracts required by app users to submit their Daml transactions. Sometimes Daml models include contracts that provide reference data. For example, an app provider may store a directory of eligible counterparties for over-the-counter trades as on-ledger contracts. Another example is financial market data, such as a stock index closing value, foreign exchange, or interest rate fixing, provided by an Oracle party and stored as an on-ledger contract. Such contracts are typically not visible to the app user's Daml parties, because maintaining their visibility on Ledger to app users' parties is onerous and because contracts with many observers should be avoided for performance reasons. Instead of managing the visibility of such contracts on Ledger, a Daml feature named Explicit Disclosure is utilized. This feature allows the stakeholders of a contract to share it out of bounds with other parties, so that these parties can include the contract with a Daml transaction submission, which in turn allows the submitting parties to access these contracts during Daml transaction processing. With explicit disclosure, a transaction that requires the submitting party to have visibility of a contract will succeed even though the submitting party is not a stakeholder on the contract. Front ends empower human end users to efficiently interact with the business process of your app. Apps that purely serve as system-to-system integration solutions might not need a front end. All other apps will need app front ends. To achieve non-repudiation, it is key that all actions taken by an end user in the name of an app provider or an app user organization are submitted via that organization's participant node from a front end under their control. Otherwise, the organization could always dispute a transaction record, claiming that it doesn't correspond to the actions performed by the end user. The app provider and each app user should thus serve the app front end from a web server under their control to achieve the best possible non-repudiation guarantees. For the same reason, each organization's front end should be configured to log in via that organization's IAM. The IAM will issue access tokens that can be used to submit commands to the organization's participant node. There's no one-size-fits-all architecture for Daml apps. Instead, there's a continuum of possible architectures. Your role as a technical solution architect is to consider the pros and cons of each architectural choice and to arrive at the architecture that provides the most suitable trade-offs for your case. To be able to discuss the trade-offs, let's consider three distinct architectures. The first is the architecture with the fewest components to build, where app users only operate the front ends, and only the app provider operates the backend. On the opposite end of the spectrum lies the most flexible architecture, where each organization builds and operates its own front end and backend. And in between these two architectures, we'll consider the one where the app users operate the front ends and the backends built for them by the app provider. When only the app provider operates the backend, app users' front ends submit commands to the Ledger using Ledger API or HTTP JSON API. To read from the Ledger, app users' front end uses app provider's backend. This architecture is the easiest to deploy, and it still provides non-repudiation and self-sovereignty of app data for app provider and app users. However, it doesn't allow integration with app users' off-Ledger systems, and it limits the possibilities for automating on-Ledger workflows. In this architecture, the backend can only submit commands to the Ledger on behalf of app providers' Daml parties. App users' Daml parties can only send commands to the Ledger through the front end. The next architecture is where app users operate the front end and the backend built for them by the app provider. When the app users operate the app backends built by the app provider, the app users gain the following benefits in addition to non-repudiation and self-sovereignty over app data that they get from operating a participant node. Self-sovereign queries over app data. App users can rely on queries over their app data to be served by their own backends that are fed from their own copy of their app data. Whether this is a requirement for your app depends on your use case. It might, for example, be required for app users that make very high-stakes decisions in a low-trust environment. It might also be required for app users that must strongly control all their decision-making infrastructure for compliance reasons. App user system integration. If an app user needs to integrate their actions in the app with off-Ledger systems under their control, then they need to operate a local backend serving as a bridge between these systems and the application. Batched access to contended resources. If there are many end users that access the same on-Ledger resource owned by the app user, then A backend might be required to batch access to that resource to provide higher throughput. For example, there might be many traders that are allowed to allocate funds out of a company's on-ledger account. A local backend allows app user to batch the trader's requests and submit a single Daml transaction that serves a 100 allocation requests in one go, which results in an 80 to 100 times increase in speed compared to serving these allocation requests one after the other. Fine-grained end-user permission management. App users might require fine-grained access control for their end users with respect to reading on-ledger data and acting on ledger using the Daml parties that represent the app users' organizations. This is best implemented using a backend that controls access to the app user's participant node and the Daml parties hosted there. The disadvantages of app users operating the backend built by the app provider include app user operating costs. The app users need operating staff that take care of monitoring and maintaining their backend. Multi-version deployments. Some app users will likely be slow to upgrade their app backend to a new release, which means that multiple versions of the backend code will be running at the same time. This makes it hard to change your app workflows and to test that upgrades will work as expected. When the app provider develops the backend to be operated by the app users, the app provider becomes a provider of on-prem software, which comes with the challenge of requiring app provider support staff. The app provider needs to run a client-facing support team to handle problems with backend operations during the app user's business hours. App provider release management. The app provider needs to release software to customers for their operations on-prem. Managing these external releases requires extra communication and care compared to managing app providers' internal releases. Finally, the architecture, where each organization builds and operates its own app front-end and back-end, provides the most flexibility in implementing each organization's requirements for automation and integration with off-ledger systems. However, this flexibility has a cost. App users that not only operate their own backends, but also build their own backends and/or front ends gain additional benefits. Customization. The app user can build the app backend and/or front end exactly to their needs. One reason for that might be the need for custom system integrations or custom fine-grained end-user access controls. Lower software supply chain risk compared to running an app backend or front-end built by the app provider or a third party. This may be required in case the necessary audits of the third-party code are too expensive. The disadvantages of the most flexible architecture include app user software development cost. The app provider always needs to build and operate its own front end and back end. App users, on the other hand, may not need to. When app users build their own front end and back end, they need budget and expertise for developing and maintaining their front end and back end code. Requiring app users to develop their front end and back end can thus severely limit the total addressable market of your app. Cross-organization software development. Both the initial development of your app and future changes require coordination across the app provider and app user organizations. Daml provides a great way to specify the APIs of the workflows across organizations. However, the challenge of cross-organization software development should not be underestimated. Restricted app evolution. You should expect the app to evolve over time to cater for new business requirements. However, app users may not be inclined to or capable of changing their front-end and back-end code, which makes it hard to change or decommission existing workflows. This table summarizes the properties of each of the three architectures we considered. Remember that there's a continuum of possible architectures in between. App architecture can also evolve over time. You may start with a simpler architecture that gives you the minimum required set of properties and add to it later as the business requirements evolve. And this table summarizes the properties of the same three architectures from the perspective of cost and other software engineering concerns. Our recommendation is to favor the architecture that requires the least engineering and operations effort from your app users while satisfying their requirements. A Daml app typically requires three kinds of components: Daml models, app backends, and app frontends. Daml models need to be deployed on the app providers and each app user's participant node. There are options for who develops and operates the app backends and front ends, and the architecture of the app can evolve over time. We recommend to initially favor the architecture that requires the least software engineering and operations effort from your app users while satisfying their requirements. This allows to minimize the delivery risk and maximize the total addressable market for your app.